Where are the Mars rovers? The evidence, Part 1. In 2014, armed with a new computer and 2 large monitors, I began a journey to study anything space-related. When I discovered I could see daily images of Mars, I settled in to learn everything I could about the 3 rovers: Spirit, Opportunity, and Curiosity. Along the way, I began cataloging images that contained changes in the equipment that seemed inconsistent and documented the anomalies in over 60 videos for nearly a decade. Those inconsistencies made me question whether the images of the Curiosity rover were authentic or staged here on Earth. After studying hundreds of thousands of images, this presentation will show that the answer lies in between the 2 choices. The ability to make such a bold claim is challenging. Short of standing on Mars, no one can unequivocally make such a statement. The images presented by NASA are the standard upon which we must make this determination. Any reasonable person would be willing to acknowledge that given the continuing advancements in technology, photography, and the use of artificial intelligence, that just about anything is possible. 2 primary sources of Mars imagery are available to the public: the forward-facing raw images on NASA's website and the PDS image archives, which are challenging at best to navigate. Early in the investigation into the PDS image atlas, it was also discovered that the otherwise black and white images were intentionally being colored to obscure the images. Why? Countless images contained sections where a green mask was curiously being applied to what were otherwise perfectly good images. Why? Here in this side-by-side comparison of images discovered in the PDS Image Atlas, we can see in the left image that the multicolor application, which is purportedly used for navigation, only covers the area where the green mask was not applied. Why would they be studying the ground behind the rover where Curiosity had already traveled? Here again, we're still viewing images from Sol 40. The top 2 images were posted in the raw images. The bottom row are what was found in the PDS Image Atlas. The strategic positioning of the green mask clearly identifies the previous and current positions of the rover in previous images. Why is the green mask used for this purpose? The application of a black box, such as in these 2 examples, were explained by NASA as image data missing during file download. Interestingly, this black box has never been used in any color image. Images like this one on the left that contains 2 black boxes from Sol 524 are eventually replaced with one without the boxes, as we see here on the right. A side-by-side comparison to confirm the images were identical was conducted with vigorous scrutiny. The results were fascinating. This close-up of the area just beneath the antenna shows where the images are in fact different. In the image on the left, we can see an object protruding from beneath the black box. That does not appear in the image that they used to replace it with. The object hangs down and crosses over where these 2 parts meet together and crosses over the shadow line. The presence of this image is significant. It only exists because of a website that downloaded it was no longer being managed or updated. All other sources, such as the raw images and the PDS Image Atlas, were updated with the new image. What is this object? And more importantly, how was a second image taken without it? This is an intriguing image from Sol 2734. Notice that the bright light reflected on the rover is inconsistent with the dark image behind it. In addition, it is clear from the enlargement on the right that material has been placed on top of the UHF antenna. The image below shows how it should appear. The debris on top breaks the circumference of the crimped edge on top of the antenna. There are numerous images that have been altered with white scratches, such as this one on the right. It's easy to do with a pen using editing software. The scratch out in the right image was one that I added using Photoshop. The image on the left is the one where the staff at JPL added the scratches to the image. And here's the one that I did to show how easy it is to do and that they are intentional and certainly not any type of lens flare. What is it that they don't want seen? This image from Sol 2051 shows the largest area ever seen that was intentionally scratched out by the JPL team. Why did they do that? Here's an example where the rover appears identical in two different locations. This has happened frequently in the raw images. Every aspect of the lighting and shadows on the rover in these two images is identical. However, once again, the bright light on the rover is inconsistent with the lighting in the background. The position of the gnomon is in the same position on both images, even though the one on the left was taken at 4:48 in the morning and the other one at 7:08. The only two differences in these two images is the background. The rover in these two images was in the same general area. This is the same rock as this one and this one over here. Curiosity is level and square with the masked camera. How did the landscape in the distance in the right image become so tilted versus the rest of the image? The remainder of the presentation will show color images taken by Curiosity with either the masked camera or Molly camera, as we see here. Both of these cameras were built by Malin Space Science Systems. This company has imaged more than 99% of Mars at 6 meters per pixel resolution and have validated and archived hundreds of thousands of images of Mars since the 1990s. They're under contract to receive and process the images taken by Curiosity and deliver them directly to the PDS Image Atlas. JPL doesn't have to do anything. Every couple of months, Curiosity uses her masked camera to take pictures of the turret at the end of the robotic arm. The posted color images have two curious photographic anomalies. Look closely at this image. In all four corners, we see a rounded edge, a curvature to the entire image. On the left side and the right side, a black strip has been added on top of what would have been the image. It appears almost as if the entire image would have been round had these strips not been there. The phenomenon appears in both the right and left masked cameras when taking images of the turret with the Mars landscape in the background. Is this a defect of Malin's cameras or photographic software? In this example, the image on the left still contains the odd rounded corners and the black border, but the image on the right does not. How is this possible? The left mast cam, the M34, took both of these images of the turret at the end of the robotic arm. How would the same exact camera produce images that appear so differently? The landscape in the left image appears farther away, whereas the right one appears very close. Here is an example where the same two cameras that created the vignetting and black border in the other images now produce two examples that don't have any. Why does the effect only occur in the images with the equipment? On Sol 1921, Curiosity decided to capture an interesting rock with its mast camera. This image was taken of the same rock by the remote micro-imager telescope known as the ChemCam. This color image was taken the next day by the MOLLE camera and shows great details of the intriguing rock that could be hundreds of thousands of years old. When studying the end of the rod-like structure on top of the rock, we can see a reflective metal opening that forms a perfect square. None of the other pieces of the rock formation appear like this one. This image was created by NASA and JPL to depict where on Curiosity the calibration target hangs behind the azimuth motor for the robotic arm. This color image, viewed from the mast camera on the deck, shows where the calibration target is attached to the base of the azimuth motor with two brackets. There's one here and the other one's out of sight. In this close-up, we can also see two lighter colors that appear as grooves in the bottom of the unit. There's also a thin piece of regolith that is resting on the arm. The arm is all the way over here and it is leaning on it. This equipment goes all the way back and this is leaning in underneath the edge and on the equipment. How is that possible? This area is at least 2 feet off the ground. How is the material balancing on this arm? Here is a second look with those grooves in the base of the unit, and again, those arms. Again, we see two of the grooves in the base of the unit. On the left, we have a color image taken at JPL during construction of Curiosity. We see where the arm of the bracket attaches to the bottom of the calibration target. The frame of the calibration target appears gray, and the base of the motor is black. How is the motor black in one image and green in the others? Is this the same rover? Here is a comparison of two images taken on Mars by the MOLLE calibration target. The first one was taken on Sol 411 just after her first year of service. The second was in Sol 1632, nearly 4 years into service. This image contains an interesting anomaly. In the close-up, we can see a round blue object that looks almost like a blue racquetball, where the motor should be seen. What is it, and how did it get there? This angled perspective of the front of Curiosity was taken by the Molly camera on the robotic arm. So now we are going to be discussing this. This is called the Material Check Display Unit, and it contains 5 cylinders, 3, 4, and the 5th one we can't see. Here we are looking down. We're looking at the display. Now this unit, this is the Curiosity's twin, and this is inside JPL. Clearly it's not finished construction, but again it gives us a perfect bird's eye view to see how the unit is put together. This is a piece where it is connected, and the bracket comes off in an L shape and is attached at the front of the deck and comes back out. This eye level view, again during construction, we still see that same part where it's attached, the bracket coming off. We can't see it, but that's where it attaches to the front of the rover. In this color Molly image, we confirm again that the bracket comes off perpendicular to the cylinder and angles back and attaches to the front of the deck. In this comparison, we are now looking at the same bracket on the left. The left image is from the front perspective of if we were standing in front of her looking backward. The right image was taken by the mast camera and is now looking down from behind. There are 2 sets of screws on both locations. We've identified one as A, so we're always looking at the same one. In this image, the bracket comes out as a piece of this bracket here. It is all one unit and attaches and angles back. But in this perspective, it has a completely different way of being attached. This unit is a completely one molded piece of unit and comes straight back from the bottom of where the screw is and is parallel to the cylinder. How is it possible for the arm of this bracket to be angled in one image and yet parallel to the cylinder in this image? If this was being viewed in this one, this arm would be coming off of here and going straight back. In the first images shown of the rover after arriving on Mars, the bracket was clearly the focus. In fact, it was made to be bright white, even though it should have been the same as the rest of the display. This is Curiosity in the early stages of construction at JPL. The metal reinforcement brackets have been attached and secured to the body. The bottom edge has been covered with a metal material and has been crimped every few inches to ensure a tight fit and to protect the bottom of it from rocks and debris while traveling on Mars. In the image on the left, the robotic arm was close to the ground to get this close-up view of the bottom edge of Curiosity. However, we do not see any of the metal crimping that we see in this image. In this image, we actually see what appears as a shiny, reflective material instead of metal. An even closer view shows odd lettering on the tape. There you can see a capital L and an O or an A, and then an R and a D. and it's repeated in an alternating upside down and right side up pattern, and it appears all over the tape. From this perspective, the tape is no longer reflective, but flat or matte in appearance. But with close scrutiny, the letters can still be made out on the tape. In this close-up view, we can see two interesting details. The metal reinforcement strips that were attached at the front no longer have any depth or raised edges to the sides and appear to be painted on the surface. Second, we can see in the shadows where the tape had to be cut around the bottom of the bracket where it was attached at the bottom of the deck. We can also see where the tape is pulling away and where they had to add some glue to keep it from pulling further away. Is this the same rover we observed with the metal crimped edge at JPL? Are the images of the Curiosity rover on Mars simply staged in front of a large screen with the rover being adjusted to show different angles? This comprehensive study has documented that images have been intentionally colored, templates applied to them to block them from being viewed. Documentation was provided showing straps being used on the equipment, tacks on the Martian surface, and materials being shaped as shadows. Should wires come from rocks, screws, or bolts be found on the Martian surface? If the images are genuine of a lone rover on Mars, how does an object appear, then disappear? Are the images presented on NASA's website of the Curiosity MSL on Mars genuine or staged here on Earth? Been answered. Why did NASA make the decision to present staged images to the world? Who authorized the decision? Does the U.S. government have the legal right to withhold their real images of Mars? Is there something on Mars that is being withheld from the public? You decide. All images presented in this presentation were sourced exclusively from NASA and JPL sources.